Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future. Our natural world is in crisis. We need solutions now. Join the conversation today. Welcome back, everybody, to Building the Future, Green Building in the New Millennium. I'm your host, Ian Sollenberger, and today, Ginger Matthews and I will be continuing our discussion on the trend toward electrification of the built environment, which ultimately means eliminating gas, propane, and other fossil fuels in our buildings and homes. Hi, Ginger. You want to tell us our specific topic for today?
Hello, Ian. Welcome to all our listeners, especially other electrification enthusiasts. So last week, I think we did a pretty good job explaining the why. Feel free to go back and listen if you want a little background on some of the challenges and many of the benefits of building electrification. So today we will show you how to retrofit existing buildings to get rid of fossil fuels once and for all, hopefully, because existing buildings are really the lowest hanging fruit when it comes to lowering embodied carbon and future-proofing the built environment. So welcome.
That's right, Ginger. Like any high-performance building design for new construction, there are still a lot of moving parts when it comes to electrifying existing homes and buildings. We've said it before, but there is no silver bullet when it comes to sustainability, other than hiring the right team.
So different projects have different project budgets, sustainability goals, so we tend to shy away from getting too granular and prescribing specific solutions before we have a real clear idea of the site, context, and size of the project. But with retrofits, there are some really helpful rules to follow and specific areas to focus on when approaching electrification. So our goal today is to lay out those for you and give you a clear roadmap of what to consider when going all electric with any existing building type.
So many of these ideas we've spoken about before during our Season 1 discussions on sustainable design. So feel free to go back and listen to learn more about the significance of sustainability in the built environment. As Ginger mentioned, today is going to be more of a how-to. So let's get started with, drumroll please, building enclosure, the all-important envelope, windows, insulation, and doors. Oh my. Definitely a first area of concern when looking at inefficiency in older homes.
Ian, when you say older homes, how old are we talking about here? Is there a particular age or class of building we should be prioritizing?
I'm really glad you asked that question because there are tons of buildings built within just the last 10, 20 years that are perfect candidates for electrification. And traditionally, we wouldn't really think about those being outdated for at least another 10 or 20 years, right? But as we mentioned last episode, methane leakage, carbon emissions, and the overall inefficiency of these gas-guzzling HVAC systems combine to make a pretty compelling argument that we can't keep relying on fossil fuels if we care about the environment, if we care about social equity and our own health. Okay, I'll get down from my soapbox now. Back to the building envelope, Ginger.
Both of our soapboxes, for sure.
Right.
Yes, we mentioned it before, but improperly installed insulation, even in newer homes, is one of the biggest factors when it comes to poor comfort and performance. So time is money. And even good GCs and subs sometimes get a little lax on a Friday afternoon when they're trying to wrap things up for the weekend. So better to make sure it's done right the first time if you have the opportunity.
Yeah, it can be really expensive to rip out drywall and replace old or improperly installed insulation. So good HVAC contractors use blower door tests, and they use thermal imaging tools to zero in on where the air leakage is happening. And that way they can focus the attention where the building really needs it. It could be that your wall insulation is totally fine, but you have old windows, right? Or maybe it's the attic or crawl space that needs that extra layer of thermal protection. Those diagnostic tests show us exactly where the heat is getting out so that we can address the problem. And I want to take a moment to point out that a home or a building is really an integrated system of smaller systems that work together to hopefully provide a healthy and comfortable indoor environment. So ignoring smaller issues like improperly installed insulation or uninsulated ducts or unsealed windows will only lead to bigger issues down the road.
So for older homes, sealing air leaks, upgrading insulation and windows are always the first step to increasing the efficiency of any building. So no, and we're not talking about installing tiny windows. We're talking about more efficient windows. In fact, it might even be larger given today's advanced technologies in double and triple pane glass. So here's another really important point to understand. The tighter the envelope, the less energy required to heat and cool the building. So the goal of any full scope retrofit should be to do everything possible to lessen those heating and cooling loads before you even think about swapping out the systems.
Yeah. So only after you've done what you can do to make that envelope as tight as your budget will allow should you then start looking at swapping out those old systems and appliances. And I'll post a link to a pocket guide that's put out by our friends at Redwood Energy. It breaks down cost and efficiency for a host of different electrical appliances, from induction ranges and ovens to electric heat pumps, dryers, washers, electric water heaters, pool pumps, mini splits, everything in between. I don't think I really missed anything there. Oh yeah, I even hit pool pumps. That's great.
There you go. The big point we want to make here is that the cost of electric appliances is pretty comparable to non-electric appliances. And electric appliances are 2 to 3 times more efficient, so leading to considerable cost savings down the road for most buildings and homes.
Yeah, that's right, Ginger. The smallest gas furnace out there is a 5-ton or 60,000 BTU system. And case studies that we've seen in Canada, Minnesota, Ohio, other cold weather states show that the average older home with some care taken to ensure proper ducting, sealing, and minimal air leakage would be just fine with a system half that size.
It's called right sizing the system, something that's really, really essential for both retrofits and new construction.
Yeah, and something many HVAC contractors don't really know enough about. In a lot of markets, it's just business as usual with 60,000 to 90,000 BTU gas powered systems without even a second thought about, is this too big or is there another way? They've got their supplier network and most everybody's happy keeping that system the way it is. The problem is it's happening to the detriment of the client.
Clients, designers, and building owners shouldn't have to be the ones asking if there are better performing alternatives. But as with healthcare and a lot of other industries here in the US, the profit machine makes adopting many new technologies really kind of difficult. So we have to learn to ask the right questions, be smart consumers ourselves, and then we can speak from experience and educate everyone else so they know what's out there.
That's a great point, Ginger. It's a timely reminder that good communication and setting those project goals early in the process absolutely essential to success when it comes to sustainability, comfort, health, and performance. I mean, the reality is that some of these electric appliances and systems require new skills and a deeper understanding of that whole house approach that we mentioned when you're electrifying your home or building.
For designers and contractors out there listening, our goal is to help you get access to education and resources so you can gain that better understanding. It's an emerging trend, so it's got to educate ourselves. So Ian, what are some of those areas you think about when installing all electric systems and appliances?
There are 3: ductwork, plumbing, and breaker boxes. Ginger, you mentioned earlier how important right sizing the systems is for efficiency. And all 3 of these considerations are related to switching from a bigger, less efficient system to a small, more efficient piece of equipment. Before we dive into those, however, let's just quickly talk about the difference between variable speed and single stage or single speed when it comes to furnaces and heat pumps.
Well, so on top of the inherent efficiency that heat pump technology provides, designers and product manufacturers have also realized that having a single stage equipment, which means it's either on or off, is not nearly as efficient or comfortable as having air trickle through the system. So
Hmm.
it takes a lot of energy for the system to turn itself on and off each time. And the better option is actually a variable speed system, which is one that can adjust the amount of air coming through the ducts. So it's kind of like the difference between dumping a bucket on your head or taking a shower, just a trickle there.
That's right. They call it forced air for a reason. But now we know there's a better way. When it comes to existing homes and buildings, trying to trickle air through those big ducts that were designed for that oversized, more powerful system sometimes can actually add to problems rather than fixing them. So definitely something to think about. Talk to your HVAC designer about. What is my retrofit project a good candidate for smaller ducting, perhaps?
This is all starting to sound pretty expensive, Ian. What are some other ways we can stay within our budget?
All about cost. That's right. It's important to keep in perspective, I think, that any increase in efficiency, however small, is still better than what you've got right now. So, assuming a client is due for a system anyway, going all electric might end up being a little more costly up front, but really pay off in the long run from having more control over energy use. And that should translate to a lower cost to operate. Um, but there are also heat pumps out there that don't actually require ductwork. So if swapping out the ducts isn't something that's in the budget, there are still what we call ductless mini splits that work just as well. They do require a little bit of creativity in design and where you place them in the home. And if you're really strapped for cash, there actually are DIY and even plug-in options that could help for the right home. So check out the Redwood Retrofit Guide for more info and different options as far as the DIY stuff goes.
So, as far as plumbing goes, I'm assuming it's the same idea as ductwork. You probably want to have someone take a look at the size of your pipes, design of the plumbing itself, especially in larger buildings that are swapping out for heat pump water heaters.
Yeah, that's absolutely right. You could be losing energy with inefficient plumbing. And by redesigning that system or swapping out for smaller pipes, you could actually help get that hot water to the spot that it needs it more efficiently and with less energy. There are on-demand water heaters as well, which don't require that heat loss at all, since it's not storing the hot water, it's just heating it up when you need it.
Point here really is that the whole house approach is so important. Each individual system, even water, can have an effect on other energy systems in the home. So design is just as important as installation when it comes to all electric retrofit. It's important to think of the whole system design up front.
Yeah, I'll quickly point out too that all these strategies, wall insulation, insulating your ductwork, swapping out pipes, ducts, etc., these can all be applied to mixed fuel retrofits as well.
Meaning a house that still has propane or gas in it, right?
Exactly. Thanks for hitting that point. Due to electricity pricing and peak demand issues, there are some critics out there of the all-electric design, and they claim higher prices overall. I would argue that that's a real simplification of the issue and that it's kind of short-sighted, considering that renewable energy is cheaper to install and to operate if we ignore the subsidies and that existing infrastructure development we talked about in our last episode.
So we'll talk more about the future of our country's electrical grid and power generation options in our next episode, the future of electrification. So stay tuned for that one. It'll be really great.
This is a great time to say thank you again to everybody out there listening. We appreciate you being a part of the sustainability conversation. And in order for us to keep doing this podcast, we need your support. So please go to our YouTube channel, Sustainable Homes of the Future, and subscribe, or check us out on Facebook, Instagram, and on Patreon now at SHF Build. We appreciate anything you can contribute, and together we can build the future today. So what do you say we talk about the Watt diet, Ginger?
Yeah, sure. The Watt diet actually has to do with how much power is needed to run all the different systems and appliances in the home. So this applies more to single family retrofits, since larger commercial and multifamily properties have kind of a different arrangement in rates and all that with the electric company, but the principle is the same either way. So you need to stay within the existing size of your circuit breaker panel, usually 100 amps for the 3,000 square foot homes. So in order to avoid extra costs for rewiring and upgrading the circuit breaker panel.
That's right. Our third element, breaker boxes. Third variable, yes, to consider that often gets overlooked or doesn't get discussed in design. And what that does is lead to overages and unnecessary complications that could be easily avoided if the designer or contractor really knows their stuff or does their homework beforehand. So there are also ways to share power with power optimizers. They have all kinds of cool stuff that can allow multiple items, including electric vehicles, to share or automatically shut off if something else needs power. So the way that works is you have your electric car sitting in your garage, right? And it'll stop. The power optimizer will stop it from charging when your dishwasher, say, needs to go on for an hour or 45 minutes, and then it'll shut back off the dishwasher and switch back over to the electric car charger, which, by the way, can actually be a backup battery for your home. That's kind of a fun thing. We'll talk a little bit more about that
Love that strategy.
next episode. Yeah. The last way to do it is, it can be as simple as just choosing products that run off 120 volt instead of 240 volt power. And that too would eliminate that need for extra power and wiring, but lots of things to consider.
Lots of different strategies out there, quite fascinating. But that conversation needs to happen up front in design as we try to hammer home over and over and over again. So coordinated design up front in the beginning is so essential. So Ian, what other areas get overlooked in the design process when it comes to retrofits?
Well, we've got two more. We've got ventilation and we have power storage. And I think we'll actually save the power storage conversation for next time, since it's still a pretty new and evolving technology, and kind of works itself in with, that future of electrification or future of power idea. So let's close today with ventilation. Ginger, why don't you explain why ventilation is so important, considering everything we've talked about so far today? But I have one question. If we don't have any leaking gas or methane in the building, isn't it clean? I mean, why can't we just open the windows, or aren't we just healthy inside?
Well, so in some cases we may be able to use natural ventilation to do the trick, but there's still carbon fumes that occur when we cook, even if you're using an all-electric induction cooktop, and we can mitigate that by installing a vent hood in the kitchen. The bathroom is another place we need some help, because we need to let all that condensation and water vapor to avoid mold and other moisture issues throughout the house, actually. So once again, we acknowledge that each system affects the others in this whole house approach.
Great points. Ventilation and filtration strategies both are important for moisture control, eliminating CO2, eliminating other noxious fumes in the home, and also for maintaining that proper amount of fresh, healthy air in the home. If you're breathing out, and you got a whole bunch of people in your home, you got a family of 6 or something like that, and everybody's breathing, that's CO2, so if you don't have some way to ventilate that out, not so great. Not as bad as carbon monoxide, but still bad. Good ventilation, proper filtration should be integrated with a well-designed HVAC system, MERV 13 or less, MERV 11, that's kind of the new standard. And really, you need to account for that specific climate zone and humidity expected wherever the building's located. The humidity and the dew point. I mean, all of these different aspects need to be considered. And we've thrown out this statistic before, but it's definitely worth repeating as we kind of close here. Americans spend 90% of their time indoors, right? So if we can devise strategies to have cleaner, healthier indoor air quality while achieving better efficiency and lower cost to operate, I mean, that's a win-win-winner right there.
Imagine how big an impact these strategies could have on a school or an office or a multifamily project where so many different people with existing respiratory illnesses interact with that building on a daily basis, or will when the time comes for everyone to go back to work and school. So, but for now, we know everyone is spending a lot of time in their homes for the foreseeable future. And what better way to ensure good respiratory health, fend off the COVID, than making sure your indoor air quality isn't being affected by toxic fumes and fossil fuels.
Yes, amen. We mentioned in part 1 of the series that change happens one step at a time. So for now, better indoor air quality and respiratory health, they're great immediate goals that can be achieved right now by electrifying existing homes. So in the short term, it makes sense. And then in the long term, as these technologies continue to scale and are ultimately adopted, electrification of existing homes works so well with what we're seeing now on the policy side. We'll talk more about battery storage, California energy policy, pretty interesting, and grid electrification, because that's where those two things meet. If the whole grid is clean, which we're moving toward,
Mm-hmm.
I don't want to give too much away for our future of electrification or future of power episode here, but that's where that Venn diagram of home efficiency, personal health, and then social equity and all of those things kind of come together in that idea. If everybody was running off electricity and the grid were 100% clean,
Clean,
then we
renewable.
would not
Yeah.
clean and renewable. Exactly. Then we would not be burning fossil fuels.
Oh, thank
Excited
you.
for that. So
Yep.
stay tuned.
We're working on it. Doing our
Exactly.
part. So thanks, Ian. One of the things we've heard that's holding contractors back is education on some of these newer methodologies. So if you're listening, you have a specific question or topic you'd like us to address, design, construction, you name it, please email us at info@shfbuild.com or subscribe to our YouTube channel and drop us a comment.
All right, Ginger, let's recap real quick here. So first off, you want to hire designers, contractors, consultants, depending on how big your project is, who understand how this whole house or whole building approach works. It's an integrated network of systems. Hopefully we've made that clear. Things to think about and talk to your project team or contractor about when going all electric. Number one, building envelope. And then we have 3 little subcategories under there: insulation, windows, and doors. Oh my. When swapping out gas heating and cooling systems for electric systems, the things you need to look out for: ductwork, plumbing, and breaker boxes. And think about that watt diet. What's my max amount of calories or amps that I've got here, and how can I fit my my power diet into that?
Yeah.
And then additionally, staying within that power budget. Talking about amps, not money there. And then lastly, with that tight envelope, you also have to take a look at filtration and ventilation. That is an absolute must.
Mhm.
So really hope everybody learned something today. Thank you, Ginger, for joining me. You want to tell everybody what's coming up next?
Absolutely. Thank you, Ian. Stay connected, keep learning, keep it sustainable wherever possible, and stay tuned for our future of power episode. Very exciting, lots of fun. So join us and you will be enlightened.
Until next time, you are watching and listening to Building the Future, Green Building in the New Millennium.